HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 344, recorded live Thursday, November 1st, 2012. This episode is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Michael Gibson, creator of the 3D modeling tool MOI.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today, I want to talk a little bit more about things that are 3D. In fact, I'm talking to the author of MOI, MOI3D.com, Michael Gibson, who's created an amazing 3D modeling tool for designers and artists. And I appreciate you taking the time to talk to me today, Michael.
No problem. My pleasure, Scott.
So I've got MOI up on my 30-inch screen here, and it's separated with top, front, right 3D. And hopefully you'll explain some of the nomenclature and the interface here. But I can only assume you have a team of 30, 40 people working on this, kind of back at the office. It's a pretty sophisticated piece of software.
Well, it's only just me, myself, and I working on it. I have an org chart on my wall that someone drew for me with my cat, my ex-cat, passed away cat, and my rabbit on the org chart. But then there's just me underneath. I'm working for them on the org chart, so there's only just one. There's only just one of me here. So.
The cat is the CEO and the CFO.
Yeah, the rabbit is the team lead.
So in the 3D space, you've got some pretty excited fans, and I want to understand some of the terminology before we dig into what this accomplishes. As I looked around about 3D, I'm seeing this word NURBS, N-U-R-B.
Yep.
What is a NURB, and why would I care in the world of 3D?
Okay, well, don't confuse it with NERDS, but yeah, so it's an acronym for Non-Uniform Rational B-Spline. And basically, it's a mathematical method for representing geometry. And the particulars of it is that you probably know what a Bézier curve is. You might be familiar with that,
of course,
from Illustrator and that kind of thing. So it's a derivative of that. It's kind of like the next iteration of a Bézier curve, where it's a smooth curve that uses control points, but it blends those points together as you move along the spline to make a curved entity. And so you can use curves and surfaces. It's used for CAD because of precision. You can also do things like exact circles and arcs and conic sections. So a lot of CAD programs that are focused on manufacturing and accurate representations will use NURBS as the basis of the geometry definition.
And is NURB a thing is it a file format, or is it more a thing like an extension of a Bézier curve concept?
It's more like a mathematical concept. So there's all kinds of different file formats that can contain NURBS, IGES, step format, various ones like that. But the word NURB itself just basically refers to the overall mathematical concept of it.
Okay, so if there were multiple 3D formats, and I see that when I say save on your application, you support a dozen of them, they might pack the bytes a different way. But when you get the actual points out that describe what the curve looks like, the NURBS are the NURBS, no matter how they decided to pack the bytes and call it a file format.
Yes, that's correct. Yep.
Interesting. Okay, so I know that a Bézier curve has some number of points, and you could start with 0.0 and 0.1, and that's a straight line. And then when you start adding points, things start getting really, really interesting. This seems like the math would be pretty complicated. Are there libraries that you would use, or does everyone who makes their own 3D application have to write their own libraries to handle these?
There are libraries that you can use, and there's a variety of different ones. I use one called Solids++ from a company called IntegrityWare. They're down in San Diego. There's some other common ones are ASYS, Parasolid. Some of those ones are expensive to license, and that's one reason why that licensing cost is one reason why a lot of CAD software is pretty darn expensive. Especially Parasolid, the pretty heavy-duty one, is a pretty pricey component to license. So there are a few companies that do custom current. A lot of times it's called the geometry kernel, the geometry library is referred to, and there are some companies that do custom make their one, but it really requires a pretty big investment of time, and you need to get people with a lot of experience in mathematics, and especially in digital mathematics and numerical methods and things like that, which is not that easy to come by, a whole big team of those people. So it's usually most of the time it's something you license because of the difficulty in developing it. And the other thing that's difficult about, so the NURBS itself, just doing something with a curve is pretty simple, but things like the extension of NURBS into surfaces is that you have like if you imagine that if you have a net of Béziers like running in two different directions, that makes a skin. Now you have a surface, and that's how surfaces are. NURBS surface are Bézier surfaces defined that way, by this rectangular grid of control points instead of just points going in one direction. Once you start dealing with intersecting those with each other and things like that, it starts to become pretty finicky calculations. So that's why it's difficult to develop a really robust one, especially because geometry comes in like so many infinite varieties. There's so many different kinds of shapes in the world and so many different kinds of conditions about one touching the other or barely grazing each other and things like that, that it's pretty difficult to test very well because there's like infinite variations,
Yeah, when I think about it in a layman's term, and by layman I mean someone who does not live and breathe this stuff like you do, I think of it in terms of a video game, and specifically the idea of quality. I think we've all played 3D video games, and there's always that sense that this is a cheap game. This guy just put his arm through the door, and the system didn't notice that he got clipped off. Or a video game where I get caught in a corner and I simply can't move anymore because, it's just not smart about that. And it makes one think, wow, this is what a cheap video game looks like. And then when a really amazing, well-produced one comes out, none of those things occur. And it sounds like it's the difference between, the 80%, the 80-20 rule, right? Getting the 80% case is easy.
Yeah. Yeah, and then the other conditions that, of course, enough people will run into to give you a lot of support questions about are the difficult ones, yeah.
Yeah. No, there's a really, really great article on Wikipedia specifically about Bézier curves. And what's great about it is that someone has gone to the work of creating a quartic Bézier curve as an animated GIF.
Yeah, that helps a lot to see what's going on, yeah.
And it's amazing. And what's interesting about it to me is that I can look at just a very basic Bézier curve like a quadratic and get a general sense of, okay, I see how this worked. But what's more interesting to me is the movement between the 3 points, and I'm imagining it being drawn. This helped me understand how to go from something that is a function, a continuum, into something that's more procedural. The part that I have trouble understanding when I think about things in terms of programming is how do you get from something that's so amazingly functional into something that's so incredibly procedural like C or C++? Well,
it depends on the particular. There's all kinds of different algorithms for processing the NURBS. There's some kinds of processes, especially with the surfaces, that use an iteration approach. That it's not easy to come up with a direct calculation. Instead, you try to start with a approximation. There's a method that you use that will analyze whether that approximation is very good or not, and is the stepping like a little bit to this side or to that side better or worse, and then you take one little step towards the better side, and then measure again. And many of them are this kind of iterative solver methods for doing particularly difficult things like intersections, tracing contour lines, and things like that. That's why a lot of this doesn't drive off. And then the other thing that's difficult is that the floating point mathematics are not incredibly precise on the computer to start with. You got a double precision number and it's 8 bytes, and that's you got to fit all your numbers that you're going to work with into those 8 bytes. There's accuracy issues, so you have to be. There's a lot of fiddling around with dealing with the limitations of math also on the computer. You can't just use something that is a mathematically beautiful formula but breaks down by when little tiny bits of the results are, basically tossed out the window.
So this kind of starts up an interesting discussion in my perspective about the layering process, because there's the representation of the math. You know, the NURB is the closest thing that we have to represent the purity of the math. But even at that point, you've had to set a precision value. So even at the lowest level of all of this, you still don't have infinite precision, do you? No.
They're in fact pretty, fairly limited precision in certain cases. Sometimes that crops up in all kinds of different ways. Like, it doesn't, the math on the computer doesn't work it's kind of geared, floating point is geared to working pretty well when all the numbers you're working with are of the same general size, because it's basically, that's what's floating about it, is it kind of has there's a certain amount of bits for the sort of the working area, and then you have an exponent separately, and if your things are in the same general exponent range, then the numbers interact together well, and you don't lose very much. But a big number and a small number interacting with each other, then the small number just tends to kind of evaporate out of the way.
Right, exactly what you said. That's what's floating about it. If you're working in stuff that's all within the same order of magnitude, you can have lots of precision. But if you bring something very detailed into some giant number, then things start getting messy. Yeah. Do you do this in C and C++?
Yeah, C++. I write everything in C++ these days. Yeah.
And I wonder, though, as a guy who's trying to learn languages myself, do you ever say, well, maybe I need to do this engine part in some new language, some functional language, and hide that away from the C++ because it's more suited for the kind of math I want to do?
I haven't really spent a lot of time doing functional language itself. As far as the practical application side goes, I use a lot of JavaScript as the scripting language for my app to control sort of, to do high-level control flow of my UI and things like that, like when to go through different stages in a command and set up a point picker and say, now I'm going to pick the object, now I'm going to pick the line, now I'm going to draw a point or whatever. I do that in JavaScript. Mm-hmm. So there is my app as a whole has got, some different languages in it, but I haven't done a big exploration into a whole different, functional language for the guts of it. That's a big project to do a geometry kernel in the first place. So that's one of the side effects of being a single person company is I can't bite off, more than I can chew. If I go off onto some big, huge project that's going to take a really long time, I could really be screwed, basically.
Mm. So you've got an application that is also cross-platform, right? This runs on Macs?
It does now. That's the most recent thing that I've done is I've just recently finished a port. I finished it maybe a month ago or something.
And is that the same source code base and just you've if-def'd your way all the way to Mac?
Yeah, same source code and for a lot of the cases, same binary because I use this system called Wine that can actually load Windows TE files and execute their machine code. So I actually compile. I don't have if-defs. I have a few if-defs. I have a few if-defs for certain key areas like the file open dialog and things like that. But for the most part, I actually load the same binary and run it over there.
Well, that's interesting. That's almost like cheating, isn't it? The Wine is the Windows emulator.
Yeah, some Mac people do think it is cheating. Tell me that, but some people don't like it. But I put in enough native development on there to get some key points like the file open dialog mm-hmm. and color picker and things like that to be native. So I've done just enough work to kind of make it not look too weird.
But I think from a pragmatic perspective, I mean, you're one guy, and why the heck not, right? That got it working, and I assume it looks exactly like it does here. It looks great, and you've got this. You have a unique style already. I mean, for people who can't see it, I would describe it as what we used to call owner draw. So, your save button looks like your save button, and your toolbox looks like your toolbox. You're not using native controls.
No, I have my own controls, and that actually doing that made it a lot easier to do the Mac port because I didn't have to try to rewrite everything. It's not as weird when you have everything owner draw and a custom look to everything. It's not as weird then when you have that custom look somewhere else too. It looks the same there. Once you have something custom, it makes more sense to have that same custom look everywhere, and that greatly eases the porting, because that's one of the trickiest parts about porting is if you're trying to make everything different on each platform, now you've multiplied your work by a huge amount. And then once you multiplied your work, it's really easy for one of those ports to become the main one, and the other one to always be lagging behind because there's extra work involved in bringing that port, implementing new features or whatever. So I really didn't want to do something that with the Mac port that would then add to my work later on in the future,
Mm-hmm. Yeah. Well, if one looks at your application not like an app with a whole bunch of buttons, like, a text boxes over data business app, which when ported over to a Mac with Wine would look like a Windows app on a Mac, but instead looking at your application as if it were a 3D video game where everything is blitted to the screen.
Yeah.
Then it makes a lot of sense. You made the right choice.
I had a sort of Mac-ish vibe about it even on Windows originally, so it's sort of like the tab controls or were kind of a little bit Mac influenced in their look and everything. So it was actually somewhat of a hybrid to begin with as far as the UI feel goes, So, and that makes it so it doesn't stick out like a sore thumb as much, at least in my opinion, when you have the Mac version. I also have quite a few people who use both a Mac and a PC, and having the same UI is great for those people. I've heard from quite a few people who have, it's not uncommon to have a PC as a desktop and a Mac for a laptop.
Yeah, absolutely. Well, and Wine is actually the acronym Wine, WINE, means Wine is not an emulator. It's actually translating Windows API calls that you make into calls that are compatible to Linux or Mac OS. So it's not really an emulator as it is a shim.
Exactly. That's exactly what it is a shim library. So actually the performance is really great because it doesn't run in a virtual machine or doesn't do heavy lifting. It only comes into play at, API calls, and then it just basically turns around and calls the equivalent API on, Unix.
Yeah. Yeah, it's a big thunking layer over all of the things that you would need to worry about. That's great.
Now, the tricky part about it is that it also doesn't perfectly emulate things, because of that. My earlier versions didn't work very well with it, and I did a whole bunch of dependency elimination for my recent version in order to be able to do this Wine at all. The more I took more things to be built into my own package and less things dependent, less logic dependent on things like Internet Explorer and things like that.
Mm-hmm.
So once I removed more dependencies, it gets easier for Wine to be more compatible with your code. The more that you are connected to all kinds of different platform things, the least likely it is that Wine will work. It doesn't work perfectly. So.
Right. So the more the code is owned entirely by you, the more likely it is to work under Wine. If you started bringing in third-party dependencies, then you've got to figure out whether or not. That might be a blocking issue. That such and such a third-party library is just not going to work on Wine, and now you're stuck.
Yeah, and also if you have dependencies on complex platform libraries as well. That's Wine will have difficulty with, like it has difficulty with a lot of .NET stuff. Even you can't do current .NET stuff with Wine at all.
This episode of Hansel Minutes is brought to you by Careers 2.0. Careers 2.0 is a new service by our friends at Stack Overflow. You're probably all familiar with Stack Overflow, the online Q&A resource dedicated specifically to programmers and programming-related topics. Well, the team at Stack Overflow created Careers 2.0 to provide you with access to great jobs and introduce you to a bunch of great companies that you might consider working for, even if you're not currently looking for a job. Think of Careers 2.0 as a programmer profile. It gives you a platform to show that you're awesome by featuring your proudest contributions to Stack Overflow, GitHub, SourceForge, Bitbucket, anything programming related. You can even add your favorite programming books from Amazon.com. Profiles on Careers 2.0 are free. They're easy to get started, especially by importing your LinkedIn profile. However, there's one catch. Profiles on Career 2.0 are invite only. They did this to keep out the spam and have a high-quality environment. Fortunately for you, as a Hansel Minutes listener, I've got your back. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. www.stackoverflow.com/HM. I hope you like it. Where does your application fit in the kind of the strata of 3D applications? The one that reminds me the most of your application is Google Sketch It Up.
Mm-hmm.
And I would think that is kind of your biggest competition, except you charge and they're free. How do you deal with that?
Well, SketchUp is pretty different from me. I mean, it's got the thing that's nice about SketchUp is it's focused on being easy to use, and they've done a great job of keeping that alive through multiple revisions. That's one of the things that's really tricky with any kind of software that's trying to do something complex. Is every version people are clamoring to add more things in. And it's pretty easy for you to lose the simplicity of just by simply jamming things in there. Mm-hmm. So they've done a great job of keeping it streamlined and simple, but their focus is still, they're best suited for what they were originally designed for, which is architectural modeling, things that are boxy. They're not based on NURBS. They're based on polygons only, so they don't have any kind of truly curved surfaces. If you try to build a sphere in SketchUp, it's going to be a bazillion little triangle faces, even though they will shade it to look smooth. It's a shading trick only. It's not actually smooth geometry. It's a whole bunch of little facets. So it's clumsy in SketchUp to do things that are smooth and curved almost of any kind of curves. Mm-hmm. There's no curves. Everything is only line segments. If you try to draw a circle, it's a whole bunch of little lines only. Mm-hmm. And in architectural modeling, that's not a big problem because things tend to be boxier. The forms are larger, sharp corners and things like that. And it's really well suited for that kind of design. It works great for its original sort of class of targets. But for industrial design, for people doing like jewelry design, things that might have smooth flowing forms in it, that's not a great fit with SketchUp, and those things work better in MOI.
Interesting.
So SketchUp has no NURBS, is basically what it amounts to.
Everything's polygons.
Yeah, polygons only. That's the big difference. Now, the thing that's nice, the thing that is the comparison between the two is that I try to really focus on the ease of use, and that's another area where they focus on really well too. So that's the area where there's a good comparison between them. Mm-hmm. And that's the difference between that I've tried to position MOI in the scheme of CAD programs is being in the easy-to-use segment, which is not really there in CAD programs in general, because historically CAD programs have been for mechanical engineers, people doing sort of, manufacturing design, on a pipeline for doing, bazillions of aircraft parts, or, making people that have a lot of training and time invested in, all this kind of technical, mechanical discipline stuff, engineering work. But there's a whole lot of people, especially artists, doing metalwork, jewelry, all kinds of different things, who don't have that sort of super technical mechanical engineering background, but could use CAD to help them with their work. That's the kind of person that I'm trying to reach with MOI, because I'm trying to make it easier to use this kind of CAD NURBS tool set, and trying to simplify things to make it work for these kinds of users who could benefit from CAD, but who don't have much of a shot at paying $4,000 for SolidWorks and then having to go to 2 weeks class to learn how to use it, and continuously try to pretend like they're a mechanical engineer instead of an artist or something.
Well, that's really interesting. That really, for me, kind of cements in my brain where these things fit then, because I see Sketch It Up being useful for putting together, kind of in-game models or models of buildings that I might want to put into Google Map or Google Earth. So it's a way of having those kinds of modeling be more accessible. But your application is more of a Sketch It Up for a full-on CAD application.
Yeah, that's right. Yeah, SketchUp works particularly well for buildings and architecture work that's got this semi-boxiness to it.
Right.
And something that's more like products, or consumer products, or a coffee maker or something like that, those are becoming less suited for SketchUp and more for CAD. and I'm trying to, and I'm basically a CAD program, but I'm trying to be easy to use CAD program.
Right. Yeah. It's an accessible CAD program, which brings me to the next obvious thing. When would I be able to load something up into MOI and then say print?
Well, yeah, I don't. So you can save to STL if you want to do a 3D print. You mean like to
Exactly.
want to make a 3D printer type stuff, or do you mean 2D print?
I mean 3D print. I guess what I'm saying is that this seems like, of all the things that I've seen people creating their 3D printing models in, this seems like the most friendly. And I just talked to Bill Steele, who has a 3D printing product called the UltraBot, and it just seemed like there's so many pieces of software cobbled together to get printing to happen. Can I print with your product into a 3D printer?
Yeah. In fact, I do have quite a few people using it with that. There's this guy who uses it to do. So one of the things that works great with 3D printing right now is jewelry design, because it's a natural fit for the size and the process of 3D printing, especially for like the build size that they can do and everything. So I have people doing jewelry design, doing 3D printing. There's a guy who does it to print out to make custom parts for his railroad, like scale railroad, working railroad thing. That's the old metal parts that he needs to make custom replacements for. And the process is you just save to an STL file. That's the format that 3D printers use most frequently in order to take their data in, and I can just save right to that file. And so you don't print directly from MOI. You save to STL file and then shove that STL file into your printer's software.
Oh, okay. So how does someone get from, other than 3D printing, which I understand. I understand that I save as an STL file, I import it, and then it's sliced up, and then it's sent off to the 3D printer, and I understand how the printer extrudes plastic. But like, for example, on your homepage, there's this interesting looking, what I presume is metal piece of some kind, or if I imagine that gentleman making a metal piece for his model railroad, do I take one of these file formats to a machinist? How do I get one of these things out of steel? How do I make something that's more substantial?
So there's quite a few pretty different methods of generating your 3D object. There's CNC milling. There's people that do cabinetry and carve wood and stuff, and that's a subtractive process where you take that can work off STL, but it can also work off of NURBS file formats. Where they will you take it into what's called a CAM program, and they calculate a cutting path for the tool. They analyze the shape, the geometry, and they will trace paths over it in order to calculate where the cutting tool has to travel in order to carve your shape up. That's called CAM, computer-aided manufacturing, and so that's a different process than the additive process of 3D printing. But it's also a very frequently used method for construction also. Another way that you can do that people do, especially for jewelry, is that you 3D print a base thing and use it to make a mold, and now you use that mold to pour metal in to actually make the metal form. So it's sort of like a two-step process. 3D print to build the core piece, and then build a mold from that. Now you have the mold to use for making your metal. There's some new 3D printers that print metal, spit out little metal particles or something anyway, that prints metal directly too. That's a kind of a new coming thing, actually.
Oh wow! So all that matters though is that I've got that file format, and I'm clicking save right now, and I've got 3, 4, 5, 6, 7, 8, 9, 10, 11 different formats. I can move anything I want from your application into any other application that accepts this NURBS format.
Yeah, now some of those are NURBS formats and some of those are polygon formats. So some programs will only take, especially ones that are focused on animation and rendering, which is a whole other kind of thing that you can do with rendering is a whole other thing you can do with your 3D models. It's kind of like a simulated environment where you set up lights and materials, push a button, and then it will make a virtual photograph of your object that looks really realistic. Those kind of programs usually take polygon formats. So I can save to either a NURBS format where you get the NURBS data directly, or a polygon format where it will convert it by a tessellation process and dice up the NURBS surfaces into little facets to output to the polygon to the program that understands polygons.
Oh. So I can use your application to make stuff that is physical, or I could model characters and then move them into a game.
You can, yes. Now, so for characters, usually CAD is not that greatly suited for things like faces and creatures and what I would call normally, say, characters, because CAD is focused on constructing things from 2D profile curves. It's sort of like that's where it shines the most at, that technology, modeling technology, is by drawing plans and using those plan curves, those 2D curves directly as part of the model construction by extruding and revolving and cutting. But, a creature or a face doesn't have very much of a 2D nature about it at all. Like you can't define a human face only by a profile curve, because the profile curve isn't what I would call like a defining characteristic of the face. It's only just like a snapshot of it at one little angle,
Oh, I see. And then there's texturization and things like that as well.
Yeah. So for characters, usually that's done in a different style program, something like Modo, Maya, Cinema 4D, 3D Studio Max. Those are programs that are oriented towards animation and movie effects and things like that. Those are usually where people go to model characters, and they use a different process there, which is polygon modeling. Subdivision surfaces is a method of taking a polygon hull and smoothing it down to make a kind of melted, like, smooth surface out of it. It's a different technique than NURBS modeling that's more often used for character modeling.
Might I use NURBS modeling to create, like, weapons or tables and things that are kind of around the character?
Yeah, it's a good fit for that, because basically polygon modeling works great for things like a skin or a face or something like that, but it's not good at building mechanical objects, because Booleans don't work very well with polygon models, but they do work well with NURBS models. So things that are more look like they're man-made, manufactured things, those are the things that work really well with NURBS technology. Things that are that don't have very much of a 2D nature about them at all, that you wouldn't see like a blueprint of a human face, for instance, right? With dimensions called out on it or whatever, like you wouldn't see that. There's no line, there's no flat line anywhere on a face. Things like that then are not very well suited for NURBS.
So I had two other questions, and they're kind of random. They don't flow like the last questions. The first one was how do you unit test something like this?
Well, I don't do unit testing. I just get in and draw some things. Like if I want to test something, I'd build a model that uses the features that I've been working on, and I just kind of draw for 10 minutes or something like that, and just use it and exercise it. So I don't really do any formal unit testing myself, but I do, work it directly.
How would you find something like a regression of some kind? If something, you broke some feature from years ago and you didn't even realize it?
Well, that happens sometimes. I mean, especially happens in library updates from, new geometry library versions. And it's not unusual for tuning one geometry problem to then cause problems in another one with things of tolerances or things that are barely, all kinds of these special case conditions and things. Well, sometimes those don't get tested until someone tests them in the beta version. And I try to put out, one of the things I try to do is I try to have beta versions released frequently. I don't save them all up until I'm ready to release. I put them out continuously as soon as I have anything new at all, so that they get tested by users pretty frequently.
Okay, and then the other question I had was that I know that you are a big fan of pens, and then you were really kind of on the forefront, 5-6 years ago, doing, encouraging people to use pens and pen tablets and things like that. What do you think about a version of your software for an iPad or a slate?
Well, that was kind of like the original concept for MOI, was to like carve out. The original concept was sort of like, I saw that people using pen tablets struggled with CAD software. They didn't work very well with CAD software. So that was my original concept, was to make my software be pen tablet friendly, which at that time, maybe 8 or 9 years ago, meant like the Wacom style, pen tablets, digitizer pads. And that's what really drove me to try to do a different kind of UI and, think outside the box or whatever. That's become less of a focus for me over time, because most people that I've found that are attracted to the software are just just focus mostly on ease of use and not on specifically on using with a pen. So I like my actual pen tablet users are I think in a minority of all my user base now. So it's become less of an actual focus for me. I still like to consider it because it sort of kept me. It sort of is what jolted me out of just doing the same kind of thing as everyone else initially. But it's not that big of a focus for me now. And for drawing, it feels like finger painting, trying to do something precision with your fingers only. It seems weird to me.
Well, I assume that they would have some kind of a there is a pixel precision pen for the iPad now.
Yes, yeah, there is, but it's like not everybody has it, and it's
you don't want to tie your application down to that one tool.
Yeah, so I don't know about that. It seems like it's so focused on touch. And touch with precision drawing is a sort of a I don't know, that doesn't seem like a great mix. Mm-hmm. I don't know.
Well, this is really great. I really appreciate you taking the time to chat with me today.
No problem.
So folks can go and they can actually download a trial of MOI at MOI3D.com. It's extremely affordable and really sophisticated and a lot of fun. And you can check that out. And there's only one guy, so if you're in the forums asking for support, you're going to be talking directly to Michael. So that's great. Thanks a lot, Michael, for chatting.
No problem. Thank you very much, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.